Hello everyone, video 3 of module 2. This video is mainly about defining material properties and section properties, but before I start the main subject of this video, a couple of things that I didn't have a chance to share with you in video 2 because of the length of the video. I'll talk about them and then we will back to the main subject. For shell elements like frame elements, as well you can divide and also you can merge them, and for frame element you can join elements and here you can merge them. So if I select some elements that, for example, I want to merge them together and come here into edit area and merge area, I can merge them together as one element. And you have the same facilities for actually dividing. For example, if I choose this element and come to here and come to this cookie cut for selected frame line and apply, you can see that now I have this and this separately. So that's what for shell that I didn't have a chance to share. And the other thing I want to share with you is a powerful tool for drafting. The name of the command is extrude. You can extrude point to line or extrude line to shell or shell to solid element. Shell to solid element is for advanced session, but I will show you these two. For example, I want to draw a column from here 3 meters height, say 2 columns above each other. So I will select the point I want to use as a base of the element, and then I can come here in either in left side in the command line, extrude point to frames, or I can come to edit, extrude points to frames. And I can choose any section I want. Currently we don't have any section, so it's a default section. And you can choose, for example, the height you want to have. For example, 4 meters. I want 2 elements with the height of 4 meters start from here. When I press OK, it's coming like that. You can give angle in any direction if you want, that works. So for example, currently we are in YZ. You can give in all 3 directions, but I'm just trying one of them. So say 4 and 2. I need one more, and if I press, you can see it's coming this way. The other command is for creating shell elements. So if I come here, for example, select this line, and I can see here extrude line to area is active. Also I can come to extrude again line to area, and if I select this one again, I can choose a section if I have different sections for shell, and then I say what I want to do. For example, I want to choose here 3 meters height, just one shell going up from here. And you have this, sometimes you just draw a line in actually to draw the shell elements. You actually don't need that line. It's just a base for you to create the other elements you need. So you can choose this option, delete source objects, or you can keep it if you want, and then you can draw it like that. So these two actually commands are very powerful, especially when you don't have enough flexibility to draw it. You can give the directions and it can be easily drawn by SAP. Okay, now let's get back to the main subject of this video, which is defining materials and defining sections. So for define material, I need to come here and choose this material, or in the top menu you have the same here if you activated the top menu, define materials. Either way works. So I'm coming here. Currently those are American standard materials, and these two, I think this is different, but here already they are used, so you cannot delete the material. What we do, we start adding new material based on our local standard. It could be either user or any of those standards that you have in the template when at the beginning. If you are not using any of them, that's perfectly fine. Use user. That's what I'm doing because I want to use Australian material. So I'm creating few different materials: rebar, steel, concrete, and masonry for you. So here there are a few other options like aluminium, cold form, tendon, and there is no masonry, so I need to use other. So I start from steel and I say okay. Now it gives me this option. I always use different color for different material. So, and the other thing I do, I'll always put a name that is understandable for me. So, for example, in Australia, we have grid 250, 350, and 450 megapascal, which is addressing the yield stress of the steel. So I want to, for example, create a steel grade 300. I mention here steel grade 300, so it's clear for me what I'm doing, and I choose a specific color for that always for material and sections. I'll tell you why. Then here I start adding the numbers I want. So here is the standard unit you have here below, but it's really up to you guys. You can change it during the addressing the actually materials. For example, tons per cubic meter is more understandable for mass or weight, so you can come here and mention tons and meter, and you can see if it's correct or not. And then you can change it back. For example, I want to give the module of elasticity, so I'm using Australian local standard for the actually units, so that units are megapascal here. So I'm going to Newton and millimeter, and I'm adding the numbers I want. For example, 2.05 E5, and then Poisson ratio for steel is 0.3, which is correct. Coefficient thermal of expansion, because I choose a steel, some of them are by default here, it's something around 1.2, 1.17, so I keep it as it is, but you can change it. And then the minimum yield stress of steel. So there are two groups. One is the minimum, one is the expected. So sometimes expected is a bit higher than minimum, so you can specify here. It's up to you. So this is 300 grade, so I can put here 300, and ultimate stress for this is 430 megapascal, and then here is expected yield. It could be a little bit more. It's really up to you. Currently I am putting this one the same, but you need to really check your local standards and see how you want to deal with these actually options. And then you can choose these units anytime you want with different units, and you can see actually they can easily be converted. Some of them automatically calculated by software. So for example, shear modulus, you don't need to input anything. You can switch to advanced property and going for some non-linear behavior, but this is out of the scope of this course, so I will leave it as it is. And so this is currently a steel grid 300. I will press a steel grid 300 coming here. I'm adding another property. I'm using rebar this time for the reinforcement, so I keep it as user again. I'm coming here, rebar, and for rebar, okay, for example, color is green this time, which is okay. And then material grade for rebar is 500, and the name we have for rebar is deform shade bar 500 megapascal normal ductility. So this is how they name it in Australia. You can do whatever you want in your local standard. That's perfectly fine. You don't have to follow exactly what I'm putting here. Again, I can check the actually a specific unit volume and everything here, and I can put the numbers here. So for rebar generally is a little bit lower than steel, so it's 2E5, and the coefficient is a little bit higher, generally 1.2. Some of them are really doesn't affect your design, so you really need to see how much you need to be precise in adding the actually details. So here is 500 for rebar, and ultimate is a little bit more than 500, about 8%, so it's 540. And again, it's up to me. I will keep them the same, 500 and 540. But if your expected yield stress is a bit more than the minimum yield stress, you can put more number here. Again, you have switched to advanced property, which is not the subject for this course at the moment. So I'll press OK. So I have rebar, the deform shape 500 with normal ductility. The other material I can add, again, I'll keep it user, and coming to concrete and use, I don't know, maybe I want to change the color to gray or anything else. It's up to me. I can change the color here, and then I can see what units I have. So if I come to ton force meter, it's 2.4, which is correct roughly, and then I'm coming to Newton and millimeter again, which is my standard local units, so module of elasticity. Okay, so concrete name, sorry I forgot. So here we can mention what type of concrete I want. So concrete, what I'm using is 40 MPa. So this is the material I want to actually introduce here. So the module of elasticity for 40 MPa concrete is 32,800 megapascal, and then Poisson ratio is 2, and thermal expansion is something around 1 e minus 10. So I can put this, probably is more accurate, but that's one I'm just showing. You can change if you want, and then this is automatically by software, and then here specified concrete strengths and extend expected concrete strengths. So I put both of them 40 megapascal. 40 megapascal. You can choose lightweight concrete, then you need to put what's the strength shear reduction factor, again based on your local product. So yep, all good. You can put the material grade here as well. So let's see if I put here 40 MPa and press OK. So the name is concrete 40 MPa. If I want to create another concrete grade here, I don't have to repeat the whole process. I can simply come here and mention add copy of material. So let's try this one, for example, for 50 MPa concrete. So I will say concrete 50 MPa. And then here it mentioned 50 MPa, and I'll change the color. I don't know, for example, to this, or a bit more different, maybe purple. And the rest are okay, so I'm not changing all of them. I'm just changing whatever I need. So that saves a little bit time. So 50 and 50, and then here the concrete strengths would be here, the concrete strengths would be 34,800. So I'm just putting here 34,800, and then I press OK. So I have concrete 50 MPa and 40 MPa. There's a small issue here. OK. Okay, so now I have 40 MPa concrete. For example, I want to add another grade of concrete. I don't have to come and add new material and repeat the whole process again. Simply what I can do is I can come here and add copy of material, and then I can rename it concrete 50 MPa, then change this one to 50 MPa. All of them are okay, so I don't need to touch them. I just change whatever I need. So module of elasticity for 50 MPa is 34,800, and the strength is 50 MPa here, and I put 50 MPa. The rest are perfectly fine for me. I wouldn't touch it. So when I change the module of elasticity, this one was changed. So if I just show you, if it's 32, you can see this number is different. Now when I change it to 34, now this number is different. Okay, so I have concrete 50 MPa. I will change the color to, for example, something different, and press OK. So I have 40 MPa and 50 MPa concrete. The other material I want you to show how to create is masonry. So I'm coming here, add new material, and because the material is not defined here, you need to go for other, and then Let's start here. For example, mention masonry. It could be block or brick with different grades. We just mention brick simply here, and I want to put, for example, the unit weight. So I'm more comfortable with kilogram force and meter. I'm coming here. The unit weight of that specific brick I'm using is 2000 kilogram per meter, and then I can change it to Newton and millimeter to input the rest. The module of elasticity, again, it back to the type of brick and mortar, but roughly for this one is 3850 megapascal. Poison ratio for brick is not too high, so it's about 0.01. Thermal expansion is something around, say, 8.5 E-6. And shear modulus automatically will be calculated. And I can change the color here to like orange or anything I want, to make it clear for myself, and then I press OK. So this is how we can define different types of material. You can see that the names are very clear for you. So that's enough for defining material. Now we are going to introduce different sections. So for defining sections, you can come here, define section properties, and see what you want to introduce. For example, currently I want to add some frame sections. So I'm coming to frame section, and I can add a property, or that means manually everything needs to be created here, or I can import a property. So if I press import new property, I can choose what type of section I want. For example, wide flange, wide flange, and then here SAP gives me the option to choose any standard I want. So you can go for any local standard you have. For me is Australia and New Zealand standard, so I'm choosing this one. Press open, and then I have all sections I need here. So I choose one universal column section for my columns and one universal beam sections for my beam. And so I'm coming here, and if I go down, for example, 250 UC72, I want to choose this one. And this is IY flange. Here I need to change the material property. If you've missed it, that's perfectly fine. You can do it after creating, but currently coming to a steel grid 300 and press OK. So it gives me this one, and I have all those materials here. As I said, you can change the material property here if you want. So this is a standard section. I don't need to do anything. All I need to do, definitely, I will go for changing the color. So for vertical, generally I use a darker color, and for horizontal, lighter color. Just give me a better view, especially for shell. So I choose this color, and I can see all section properties here. Again, this is based on the unit you choose. So if you want to have a different units, what you can do here, you cannot actually change it now. You need to press OK. You have this one. Again, press OK. You can come here and change your unit to see it differently. So if I change this one to Newton and millimeter, and again back to define frame section, can be done here as well, or coming to the menu, define frame section, then I can come here and say modify show property, and going to the section property. Now everything is based on Newton and millimeter. You can see it here. Okay, and you can use these set modifiers. Sometimes you need to change the stiffness of element. It's very useful, this one, for concrete, because of the crack section we need to reduce some stiffness. So I will show you there. For steel is generally 1. So let's add a universal beam. I can go for add a copy of property, but if I do that, that gives me actually the same section, so it's not very useful here. If I want to use if I customize this section, it's good, but when I want to create a section, better to go to import and use, for example, wide flange, and it's automatically show me the standard I chose, which was Australian standard. Again, I'm coming to grade 300, and this one I want to use a universal beam, say 250 UV. here 31, for example, 250 UV31, and it gives me this. I can keep the color, I don't know, for example, green or anything I want. A little bit darker probably would be better for frame elements. And then all of them are good, so I don't need to change anything. Again, you can play with set modifier, and you can see the section property. Some of them, like time dependent properties, those are for advanced sessions, so I'm not going through this. If you want to change your mind and you don't want this, you can come here and import again something different. For example, you said, okay, I wanted a lighter section of 250. So when I'm coming here, 250 UV31, I can choose 25 and press OK. So it will be changed to 200 UV25. So all those parameters will be changed. So this is for beam. Okay, the next section I want to create here is for bracing. So I'm coming here, import new property. I want to choose double angle. And I can see a note here that double angle section is not in this library. It doesn't mean that you cannot create it, but it's not a standard section. So what we can do, we can create cancel here, and I need to import a property, but instead of double angle, we simply go for angle, and in the angle we choose, for example, say 90 by 90 by 10, and then I press OK. So this time I just didn't change it there, so I'm coming here, simply change it to a steel grade 300 or any grade I want, and change the color, I don't know, for example, to red. And I have this one, all section property and section modifiers, as I said, all of them are the same. So I press OK. Now I want to show you how to create double angle section by using Section Designer. Section Designer is a powerful tool in SAP to give you the flexibility to create non-standard sections. I'm not going through all features of Section Designer. There is a great watch and learn video in watch and learn website of CSI that you can have a look. I will send you the link. To use Section Designer, we press add new property. Instead of using any of those standard material, we choose other. So before using Section Designer here, I'll just briefly explain you about the other options. General is just to add geometrical specification of a section without any clear dimension about the section. So by doing this, you have a kind of non-defined section, but all the specifications in section property, if you import it, they would be correct. So you have a correct interaction in analysis, but it doesn't give you the flexibility for design if you need to design that specific section. So I leave it, and again, for non-prismatic sections, there is a good watch and learn video. Again, you can have a look at this. This is for section, actually elements with different size of section at each ends. Generally, we use it for Poltar frames. So Section Designer. Section Designer, when you click on that, you can put the name of your specific section, like double angle 90 by 90 by 10, and then I can choose the material I want, steel grade 300, and either I can leave it without check or I ask to do the general check. Now I change the color to the color I prefer, so for that angle was red, and now I click on Section Designer. So this is the environment we have for Section Designer with quite a few tools here. As I said, you can have a look at CSI Watch and Learn video about Section Designer to see all those features, how to use them. So to create the double angle section, I'm coming here. There are two sections available here, double angle and L section. If I choose double angle, I need to have exactly a double angle section ready in my library. Because I don't have it and I have just single angle or just one angle section, I click on that. I'm coming here and press this. Now all I need to do, I need to match the section with the section I prefer. So if I have quite few angle section here, I can see all of them here. I choose this one, steel grade 300, and you can see the units are in kilonewton and meter. I press OK just to make it more clear for myself. I change it to Newton and millimeter, and also I zoom in here. Again, right click. What I need to do, I need to move this angle to the other side of grid Y. So the center here is not center of geometry, it's just simply half of the width and half of the height. So it's 45 millimeter and 45 millimeter because angle is 90 by 90. So if I want to move it 5 millimeter far from grid Y, assuming a 10 millimeter plate at the middle, I can change this X center to 50 and I press OK. Now I have one of the angles. I can again go and draw another one, or I can replicate this one. I can select this, come to edit, replicate, and I choose mirror around y-axis, so this coordination is correct, and simply I press OK. Now if I come here, I can see the section property. So this is for double angle. I press OK, I press done, and again I have the modifiers here. If I want to change the stiffness, I have the properties here, the same as the property I saw in the section designer environment. I press OK, so I have a double angle section. So guys, this is the end of video 3. In video 4 I will continue creating concrete sections, and also for frame elements and also shell elements.